Okay, welcome back. Um, should we lower the shades? Is it clear to see it? Like the people from the back, can you see the projector? Is like the font clear? Dante, are you able to see it well? What about you, Sergio? Sergio, are you able to see good? Cool. Okay, so we were looking at what a constructor function is. You can remind me what it is, or even what is good for. Like, why would we want constructor functions? Hugo? I could use it as a blueprint for an infinite, potentially, well, not infinite, but a big. I could reuse it to create a large number of objects that will look exactly the same and maybe even behave the same, right? So I was playing around, and I actually got my dog to salute. And I can do that if I do this. Do you remember when I showed you that you can say hello here?
Hello.
Or that your computer can say things? You can say anything you want. I'm not sure about that. Thank you. Oh.
Hello, 6.2. You rock.
So now I use that for my dog to be able to speak. So I have here this salute, which is going to be my dog, and now it's going to say hello. My name is, and that name. So let's try that with Pluto. Let's see if this works.
Hello, 6.2. You rock.
Sorry.
Hello, my name is Pluto.
Now let's try with Mojo.
Hello, my name is Mojo.
So this is the fun of programming. I hope you get to have fun. You see how we have a simple function that executes this line of code. This is basically no different than console.log. In this case, instead of console.log, I have something called CP, which is something called child process. And then I want to execute. That's what exec stands for. And then I want to execute this command. Say, hello, my name is. And then I'm using string interpolation here to be able to plug in the name there. Right? We're not going to get to deal a lot with child process. Just know you could get more into the documentation of Node. Child process comes with Node, and it allows to execute other programs from the programs that we could create. And then in this case, we're executing a program called say that somebody else wrote and is able to speak. Okay, so we have our dog constructor object, and we were able to have properties that are going to be assigned to the instance of the object. Also, that's a word I wanted to clarify. This we say the variable here Pluto, or the variable Mojo or Tom, we say they are instances of the dog constructor function. They were sort of another way, a more technical way of saying they were made of the blueprint of the dog constructor function. And in fact, we have we have in JavaScript, we have this operator, which is instance of, we can say Mojo instance of dog. I'm console logging. I want to console log if Mojo is an instance of dog. Oops, console is not a function. Console is not a function. What is console? An object. Oh no. True. Let's say I have let Mojo 2, and this one is going to be a regular object. Let's even put the breed. So now I have Mojo 2, and I'm going to ask if Mojo 2 is instance of dog. Is Mojo 2 instance of dog? No, why not? Owen? Yes, even though they're not, they have the same stuff inside, they're not equal. More importantly, yes, Hugo? Correct. It was not, Mojo 2 was not something that was created using the constructor function. So in this case, we get false. So this is another instance where having a constructor function will be useful if we want to be able to tell if an X object is an instance of a Y constructor function. Okay. Cool. So we were able to see constructor function, the anatomy. Now let's look at a problem that we have still with constructor functions. One is we have these two functions, bark and salute, right? And all the dogs that are made of this constructor function will have those two, right? The thing is, we want to, if these are common to all the dogs, we don't want to put them in every single dog. Or let's see if there is another way in which I can express that. These are common behavior that all the dogs have, right? Right now, Pluto, Tom, and Mojo, they all have their own copies of bark. They have their own copies of bark. So we could say that in this program that I have right now, we have 3 barks that are different. One is Pluto's, one is Tom's, and one is Mojo. But all of them are the same one in the sense of they're doing the same thing. They're not the same one, but they're doing the same thing. So this is where we, as often as we do, ask, are we doing this repeatedly, and where we shouldn't do it repeatedly? So let me actually show you how we do have this bark and salute. Pluto has its own. So I'm gonna change Tom. So well, actually first we need to create Tom. And I'm gonna say Tom.bark. I'm gonna change it to function. I'm gonna take this. So I'm just gonna take paste this here. So I wanna change Tom's function of bark. Maybe his barking is woof. instead of woof. Now let's have Pluto bark. Let's have Tom bark. Oops. And let's have Mojo bark. No, Mojo 2 is not defined. We can do this. We have Pluto woof, Tom woof, and Mojo woof. So what if we instead wanted to change how the dog barks for all of them instead of only for Tom? Michael? Like, okay. I think I see where you're going. You want like to pass the way that they bark here in the arguments to the function. Like bark sound. Yeah. And then I didn't think of that. That will work. But what this brings us to is that we want to put in the instance object. Okay. Yes, we could do that. But what this brings me to is the fact that in the constructor function, we want to add stuff that uniquely identifies the object that is not common to all of them. Because for stuff that is common to all the dogs, we don't want to put them here. We have some other place to put it. And that other place is called the prototype. And we don't want to put them here because in this case, there are 6 different barks. And 6 different barks in our computer memory, if we have only 3 dogs, that doesn't impact us very much. But if we have millions of dogs, then that also means we have millions of bark. We'll have millions of name, and we will have millions of breed, right? 1 for each dog. But if something it's common behavior to all the dogs, we could just have one method called bark that all the other dogs can call without having to have 1 for each one for each dog. So yes, when we have common behavior like barking, salute, we don't want to repeat ourselves giving each dog its own. We could just have one that all of them can call. And yeah, again, that we use if we leave it like this, we end up using more computer memory. For small programs, that's okay, but as you create applications that are bigger, that impact how fast they behave to the user, you will want to try to optimize, and this will be one way. Any questions here? We're going to get to see the prototype, which is next. So we said that then this is called, Pluto is called an instance of dog. It's an object that was made out of dog. More technical term, Pluto is an instance of dog. So again, like, let's say another common problem is here we have made 3 dogs. Let's say now we want to change the bark method on all of them to be a new one, to be this one, woof. Well, I'll need to do, if I want to change them, I'll need to go on each one and do Pluto module. Now they all have a new one, right? But what we want is to avoid this repetition that we see happening here. And also the fact that if we have them, we will say, here we say the bark method will be in the instance of the constructor function. So this will all be properties of the instance, right? This will always will be properties of the object Pluto. Pluto is the instance of the dog constructor function. So we say all of these will be properties of the instance. And again, we want to put in the instance in here, in the instance object, we want to put properties that are unique to the instance. That's what tells dogs apart, right? The fact that they have different names, the fact that they have different breeds. That's what we want to put here. We want to put properties that are unique to the instance. If we have something that will be common behavior across all the instances, like barking, we will use the prototype for that. So let's jump into that. Okay, so first I'm going to remove this from here. I'm going to leave what is unique to the instance in the constructor function. And now I want all my dogs to have access to the bark method. So, and I said, when we have common behavior like that, we don't want to put it in the instance. We'll put it in the prototype. That means quite literally, say dog.prototype .bark is equal to my function. So it turns out that all functions, well, first of all, functions are in JavaScript also known as first-class citizens. That means is a central part of the programming language. Functions and objects does the core of JavaScript, basically. And then it turns out that functions are also objects. This will be a little bit mind-bending, but we can see here how we are accessing the prototype key of the dog function. So this here is telling us the dog function, besides being a function, is also an object. And here we're accessing the prototype. This one is a special name, prototype key of the object. So let's look at what that looks like before we add anything. I'm going to do console.log dog.prototype. Console.log.prototype. Oh, let's get rid of these calls. Where are these? Yeah. Here I'm going to console.log.prototype. We get this. We get dog and an empty object. This is just telling us that the dog prototype is empty. And here in the dog prototype is where we want to put the common behavior that will be shared across instances, that will be shared across dogs. We will do that by, as I said, we just do dog.prototype, and here prototype is an empty object. Here we're just creating a key called bark. And then that key will hold a function that is going to be console log this name worth. Now let's console log prototype here, and let's console log it after here. Run again. What do we see? This was before we added the bar key to the prototype. This is after we added the bar key to the prototype, and we can tell that it's holding a function under that key. Any questions here? Okay, so we have prototype.bark. Let's see if our dogs bark. I'm gonna say Pluto bark. Pluto says woof. Peter? Yes. Mm-hmm. Yes, this is only to add something, not to change it. Yeah. So here we have added the bark method to the dog. But you might be wondering, how is it that the dog, we're never saying here to have a key bark and still somehow able to access the bark method? And well, let's look at what console log Pluto gives us. Let me remove these console logs of the prototype. Ooh. You can see that this is Pluto. You can see it doesn't have a key called bark. But somehow we're still able to do Pluto.bark, even though it doesn't have a key. Who thinks this is confusing? This is confusing, that's correct. But there's always an explanation. That is what I like about programming in general. There's always an explanation. Life not always has an explanation. So here, the explanation for this is when we have Pluto and we say Pluto.bark, what JavaScript is doing is checking if Pluto has an instance property called bark. In this case, JavaScript is looking at this. JavaScript doesn't find a bark property in the instance, right? In this object. It doesn't find a bark property. So if it doesn't find a bark property in the instance, it's going to go ahead and check in the prototype. Once it checks in the prototype, which we could say we do console.log Pluto. To access the prototype of Pluto, this one, it will not be prototype, it will be __ proto. So this is the prototype of Pluto. All the instances will inherit the prototype from the constructor function. So note what I'm saying. All the instances will inherit the prototype of the constructor function. That is to say, well, if Pluto was made of dog, and Pluto is an instance of dog, then that means that Pluto inherited the prototype of the constructor function called dog. Now let's look at this. Yes? That's a good question. The main job of the prototype is to share behavior across instances with avoiding repetition. Sharing, yes, there is not a lot of instances where we share variables. Most of the time is functions that all the objects should have, without actually kind of giving them those functions. We kind of just give them access to one. It's like, imagine like this is a class, and you all have you're all students, and let's say there is a method. I don't know if this is a good example, but let's say there is only one pen in the room. There's only one pen, and you don't have your own. What we were doing before, where we had the bark here, is as if you all had your own pen. Right? That would be too many pens to keep track of. Instead, we only have one, and if you want to use it, and that one lives in the prototype, if you want to use that pen, you have to come to the prototype and get it. Right. The only thing where that analogy breaks is you can have Pluto and Tom can have the pen at the same time. That's like a rule that applies in real life. Like in real life, if we only have one pen, no, we cannot have two students writing. But in programming, where we can't. Any other questions? So the prototype mainly is used to sharing behavior between instances, not having to have every instance its own different behavior, individual behavior. We add it to the prototype and we share it. So let's look at, I was saying, when we have Pluto, Pluto doesn't have a key bark. When it doesn't find the key, then what happens? Not undefined. In this case, this one is actually, that's a good point where you would expect it to be undefined, right? Because Pluto doesn't have a key bark, right? But we did add the key to the prototype. So when JavaScript looks, first we'll look at the instance, it will look at the object, see if it has a key bark. Then if it doesn't have a key bark, what does it do next? Cameron? Before it even creates one. Joey, it looks in the prototype. This will look in the prototype. So that's like what Cameron said, it will create it. Let's create one. Let's do say hi. Oh, actually, no, we don't want to create it. We just want to try to do this. Pluto say hi. Say hi is not a method in the instance, and it's not a method in the prototype. Right? So JavaScript first will look in the instance, see if there's a key say hi, and if that is a function. There is none. Then it will look in the prototype, which we haven't printed yet. But let's look at the prototype. I'm printing the Pluto's prototype, which is going to be the same as the dog prototype. Let's look at this. Now we have a kind of a couple stuff that we should clear out. Let's see that. That's the other one, this one. This is the only console log we have. We are console logging Pluto underscore proto underscore. Right? Let's console log dog.prototype. We saw that it started empty, right? Then we added one key, bark. This is to say what I said earlier. The instances inherit the prototype of the constructor function. This is the prototype of the constructor function. This is the prototype inherited, that Pluto inherited from the constructor function. In fact, if we do this, is dog prototype equal to Pluto dot prototype? We get true. They are, these two, the dog prototype and Pluto prototype, are the same thing, because Pluto inherited the prototype and it saved it as proto. So things to remember is when you call a method like this in an object, JavaScript will try to look the instance, see if it has a key bark, and if it's a function. If it doesn't find the key, it will try to look it up in the prototype. If it finds it in the prototype, then it's going to use that one. If it doesn't find it in the prototype, like say hi is neither in the instance nor in the prototype. Say hi is not a function. Say hi in this case is undefined both in the instance and the prototype. And we have say hi is not a function. Okay. Any questions? Cameron? Any other questions? So why would we want to put a method in the prototype versus the instance by writing it here? Peter? Say that again. Here. Do I want to console Pluto? I don't think I know where you're going. Here, let's see what the prototype looked like before we added anything. Oh, I guess we saw that, which is, well, Pluto doesn't exist here. Okay, I was thinking about another way in which we could demonstrate this is if we have, so let's put bark back in the instance. Let's do this. Bark function. Console.log. And let's actually, this might help. Yes. Mm-hmm.
You use prototypes so you don't affect all the other types of dog. If you only want to affect one certain dog, that's the only one. Because if you put it inside the class, it's going to affect that single.
It's not that it's going to affect it, it's that every single dog will have its own barking. And we just want one that will be shared. Yes, Joey? Yes, so if I modify the method in the prototype, at any point, all the other dogs will receive the new modified version if I want to modify the white method. Is that what you were asking? Okay. Douglas?
So by creating a prototype outside of the shared function that we're creating, does that slow down the program? Because you're no longer creating, right, every time you make a new instance of log, it's going to be filled with like 4 keys instead of 2 keys instead of 4. So that way, if you have one shared prototype,
I think you were going the right path. Yeah, it's like yeah, I guess like the example with the pen, it could also be like, let's say there's only one mic in the room. That mic will be in the prototype and it's shared for all of us. If we have that microphone in the instance, then that will mean that every one of us will have its own independent microphone. So I wanted to see if this can be more clear if I do. I'm just gonna have this is Bark in the instance. So let's see if this makes a little bit more sense. So we have this is Bark in the instance. So like I guess what I'm trying to demonstrate is that every Tom will have a different bar. So we have Pluto and Tom. They both have a method in their instance, right? And thanks to this dog constructor function, we'll have the method Bart in the instance. It's not in the prototype. Each one will get its own independent copy, right? So let's verify that that is actually true when we do console.log. If they're different, then we should see this Pluto.bark triple equal Tom.bark. What do we think we're gonna see? False. Right? They're the same. They are the same. They have the function under the key bark is the same, right? It has the same content. It will do the same thing, but they are what we call they're different references. We have two independent barks. It's not the same. So if I have here, I'm trying to compare is the barking of Pluto the same as the one on Tom to see if it's shared. I see false. Right, so that means this demonstrates that Tom has his own bark and Pluto has his own bark. Say that again? No, prototype makes them shares the method. But this is not the prototype, yeah. This is the instance. Michael. No, Cameron, sorry. We're using the instance. Let's look at that. I'm gonna comment out the method in the instance. And I'm going to uncomment the one that we were putting in the prototype. Now let's see if the bark of Pluto is the same as the bark of Tom. If what I said, that the instances inherit the prototype from the constructor function, then this should be true. See, we see true. That's correct. Yes, we cannot make them unique. And in this case, we don't want to make them unique because if we wanted to make them unique, we'll put them in the instance. But because this is a shared behavior for all the dogs, it's okay not to have them unique. And it's actually beneficial not having them unique because we will be saving memory. We only want to keep, in the instance, we only want to keep stuff that is going to be different across instances. Yes, Michael?
Be clear, I guess. The dog constructor function needs a copy of this. Each key for each separate dog. While the prototype references something else. References, I guess, a template.
So I think what you're trying to say is dog will create a separate dog for each one that we create, right? In here, Pluto is indeed different than Tom. Actually, don't trust me. What if I say this? Is Pluto the same as Tom? And here, notice that we are we're not really comparing the keys and the inside. We're actually comparing the place where Pluto is saved. Is it the same place where Tom is saved? We have false, right? So we have that Pluto and Tom are separate objects. They're independent. They're unique. But the prototype of the constructor function is shared across instances. That means we only have one prototype. We can have 1,000 dogs, but it will always be one prototype. And anything you want there will be shared. Yes, sure. Yeah, well, save memory, but like I think more importantly than that is the fact that what we put in the prototype is shared behavior. It has like the advantage of that is saving memory. I wouldn't say the goal is saving memory. The goal is having shared behavior across instances. Yes, Cameron? Yes, and the thing is, so what you said is you could have a default bark for all of them that is going to be shared, and then if you want to change the way that Pluto barks, then you could just modify that instance. So yes, that will be easier than to have if I want to change a few dogs bark, having to go on each one of them and change it manually. I could have, this could be my default bark, like all of them do bark in this way, and then I could change Pluto, individually only Plutos, if I create a different bark for it. And then I'll put that bark in this example. Let's say Pluto. So actually, let's have the 3 of them. I'm gonna change Tom. Now I'm gonna bark with Pluto, Tom, and Mojo. Also, I want to console log. I want to console log Pluto here. Console log Tom and console log Mojo. So I want to see them. Let's see. Oh, look at what we have. Let's do one more time. We have, this one is Pluto. This is the way it barks, Pluto woof, woof. And then we have, this is Tom. And now this is the way that Tom barks with a U now. And we can see that this was added, bark. This is different from all the others. And Mojo still just does the regular bark with an O. So we can see that here, by adding bark, in here we're adding bark to the instance, and therefore the rule that if the, well, not the rule, but the fact that I said when we're calling a method or a property on an object, it first will look in the instance, JavaScript will look in the instance of the object. If it doesn't find it in the instance, it's going to look in the prototype. When I call tom.bark, first it looks in the instance, it finds it because we added it to the instance. With this, we added the bark method to the Tom instance, and therefore that's why we see the modified version. We see it barking with an U. Yes, Deja? Uh-huh. Well, are you talking about like the actual ingredients and recipes?
Yeah.
I'm not sure I understand. Like we could have, well, the thing is like constructors doesn't really apply to I was gonna say recipes, because like if we think about like a recipe cannot do anything on its own. Well, I mean, we could like, this is a programming world, and we could have recipes that walk and recipes that talk, right? The way we have a dog that talks. But yeah, I'm having difficulty kind of seeing where the example. So could you repeat it one more time? I think it will be like adding another key.
No, I'm not adding another key, adding another
Ingredient.
ingredient. Every recipe, every ingredient for everything, but not the same. But in order to add more to it, add cheese.
Uh-huh.
And
Uh-huh. Yeah, maybe we can talk about it. Yeah, any other questions? Giselle? So the question is, what is exactly an instance? First and foremost, an instance is an object. The thing is, we call it instance when that object was made out of a constructor function. So here we say Pluto is an instance of dog. But fundamentally, an instance, we only talk about instances when we're talking about objects that were made out of constructor functions. Otherwise, if it's just an object that we created our own, like a literal object, we just say that's an object. That wouldn't be an instance. Sure. I can select this one now. Okay, so what else are we missing here? So I wanted to point out to when some of you, yes. To the constructor prototype, yes. Local to in the instance. Correct. You will be looking in the instance whether that's Pluto, Tom, or module. So I hope this can bring it home. When we do, you have seen that when you type array.filter JavaScript, you see that the MDN always says array.prototype.filter. And then, well, the W3 schools are using somewhat as a simplified language to explain the same thing. But here, because, well, I find that MDM is more technically correct. It's not that W3 school is not correct, but MDN oftentimes goes specifying exactly what's going on and where it's coming from. So this is saying array.prototype.filter. So what we just learned about the dog having a bark in the prototype, and we said, so what? Like, why would they put filter in the prototype and not in the instance? Yes, we seen what we just saw about having the bark method of the dog constructor function in the prototype, and the reasoning for that. Why did the JavaScript language decided to put the filter in the prototype of array instead of the instance? Vanil? Bingo. So all arrays can be filtered. So all arrays can use the filter. And filter is something that is, it doesn't matter what array you have, it will have a filter method. So the reason is to share behavior so that all arrays can have filter. And on top of that, not have 1,000 different filters that do the same thing if you had had it in the instance. So you can see that. And then by looking at this, again, almost everything in JavaScript is an object. We see that the array itself is also an object, and it has, you're keying into, you're doing dot prototype and then dot filter. So all arrays have prototypes too. And I'm not sure if we could do this. Let's see. Node empty array proto. Yeah, no, these are, we cannot see all the methods here because JavaScript just hides them from us. Let's do, what if I do? Object keys. Yeah, JavaScript just is hiding them, but under the prototype, we have a filter, we have basically all the array methods, fill, flat, join, etc. So this, look at this one, for instance. We have a length property that's not in the prototype. Why is it not in the prototype? Joy? I thought you raised your hand. Go ahead. Yes, let's see, Sergio. Correct, because we want the length to be unique to every array. We don't want to share the length, right? Because then that would be really confusing, saying we have an array of 3 elements and the length will be 3, and then if we were sharing the length through the prototype, we will have an empty array whose length will also be 3, right? This is, again, another example where we want to have in the instance properties that are unique to the instance, like length. The share behavior, like filter, we put in the prototype. Any questions, comments, thoughts, complaints? Do that.
Like if I could create dog and cats, and you have one effect instances of both dogs and cats, the same prototype. Is there a way to do that without, again, you start off dog prototype, whatever.
So that could be, I don't know the answer to that question. I think it's possible. And just so that, oh, maybe Gerard knows. So thank you, JR. So that just reminded me that we could do this to verify what JR just talked about. We could say, let's actually go back to our dogs. We were able to say, let me comment this out. We were able to say, that Pluto is instance of dog, right? We were able to say that Pluto is an instance of dog. We all agree on this. This is going to give us that exit. This is going to give us true. So dog is an instance. No, Pluto is an instance of dog. But Pluto is also an instance of object. I hope I'm right. So what this does is, well, this object, this capital object, is what all the other objects are made of. And then we have what we could, the conclusion that we can arrive at here is that if we wanted to share behavior, let's say we have a cat and a dog, and all of them have a method which is, let's say, fight, right? Both cats and dogs fight. So we don't want that method fight only in the dog's prototype or only in the cat's prototype, right? Because then it won't be shared. Either the dogs have them or the cats have them. And if we add them both to each one of those prototypes, then we end up with two different fight methods. But what we could do is we could add, and Jared, correct me if this is wrong, we could add the fight method to the object prototype, and there, because both cat and dog inherit the prototype from object as well, then the fight method will be shared across all objects. Any other questions? Yes, Joy.
You don't want to have all
Mm-hmm. I will say, I haven't done it. I'll say that I'm sure there's a way. You could have, and this is like, we're seeing constructor functions mostly because we need to deal with all code. Now there is an easier way to do this, which are called classes. In classes, that becomes more apparent, where a class inherits from another. But I'm sure that there is a way to do that with prototypes too. I haven't dug that deep. Yes, right here. That will be with classes. We can do that. I'm just not exactly sure how we would accomplish the same behavior using prototype. But with classes, we can definitely say that, and then it becomes a little bit more natural, saying we have a class animal, and then that animal we have a class dog that extends animal, and we can have a class cat that extends from animal as well. And then the fight method will live in the animal. We haven't learned that yet. That's after this. Let's see if I'm forgetting anything. So we learned that this keyword, the new keyword, we learned that a method or a function can be a value under an object property, right? the way we had our initial Pluto object, where we have bark, the key, the value was the function. We learned that the functions that we defined as properties of the instance here will be every instance will receive its own unique copy. And we learned that if we add the function to the prototype, then there's only one bark, and that will be shared across all the instances. This allows to save space as well, and just the fact that if it's shared behavior, why would we have more than one? Right? What else? Again, well, when would you decide to add a method in the instance versus the prototype? Let's try to piece some of your ideas together. When would I decide to? Why would I decide to? I guess this is kind of the same question that I've been asking. If you want to add, if we want to put in the instance properties and methods that are unique to the instance, like name, length in the array, those are unique to the specific array that we're talking about, or the specific instance. And we use the prototype for shared behavior. We want all the arrays to have filter. We want all the dogs to be able to bark. And here, it's important to note, I almost forgot this, which is, even though the bark function is in the prototype, this will still refer to the instance. So you see that this is outside of the function, right? So outside of our constructor function. But because we saw that every instance inherits from the prototype is shared. Here, when we call this when we call bark on Pluto, then this will refer to Pluto. When we call bark on Mojo, then this will refer to Mojo. So this is again that shared behavior. I think that's it. So there is there is an exit ticket. So please try to complete that now. So after you're done with the exit ticket, please get started in the lab. That's what we're gonna do for the rest of the afternoon. I think the lab is going to be due at midnight. Yeah, so get started on the lab if you finish with the exit ticket.
Yeah. This is about your C code on the file, and you really respond. It is. I saw that there are tracks. I don't know. I think it's the line to jump to because they couldn't finalize also so CBS and in 2016 because there was no we hadn't had finalized. So actually we just jumped. The standard is finalized. Yeah, that's the one. Yes, it's 2000. There's one. The number, yes, is one. There is no any new, we don't have any new versions yet. So whenever that version comes up, let's say it comes up as 0, they will be called. Yes. Yes. Well, okay, so yes, 6 is 1 forward. So it will be that yes. And then therefore. So when I say. Like, I use this different function. And since that doesn't have, it doesn't have y, so you lose the program. When you come to the program, it says, we have a y. We have a y. You what can you share? Well, it's actually here. I was just using this as as first as the segue to build this new problem. And we have a loop that says it looks like this. It has
Also, hey class, can I have your attention please? So when you go to Slack on the 6.2 app, I showed you the link to sign up for our meeting Monday, Tuesday, and Wednesday. So check it out and then sign up for it's like a quick back. Sign up when you can.
Oh, so yeah, I was talking about this here. Just to demonstrate the fact that it's very boring. Object like that. Better have that dictates what dog looks like. How they probably do it. Change code. It's cool. It's well, actually, I don't think that I have to manually create other documents. This here was created. Otherwise, they don't even know that they were there. That's a lot of things that this allows because not completely very well. I'll show you this. The more importantly, so right about the exam, both of us share this approach at the same time. And know that is considered saying that and then if you have instances, then you can say that Pluto would be of the same kind. In this case, it's of the same. Yeah, like you said. So you're saying certain functions can be related to parts of this part of it. So I think I'm sure if it's If it's online, and it was and then that's really where let's say don't see that. This could be. Still do the wrong. Will be oh, actually, no. Website. This is what we want to use. Having more than one. More. We have so that is this is like the not only specific to what I guess that big that sells anything you want. And something. I'm just going to sell fruit. And God sells. This is where that's why I have your shop. Already, wish list. Building wish list is giant. And my tiny shop. Wish list. So, in here, like this, I didn't have. Let's see. Let's have only children. Like their children. This is fully. Or all like this is this could be quite perfectly. But what is showing is the track of so yes, I think we can manage about what we can share that all of the children yes, but we can have the general tracking. So that could be Well, this one is interesting. You have, if you share behavior, which is the ability to calculate price, then you go through the items, check, add all the prices. But that's something that we want all the children to be able to. Right. Another way, this is not missing, but another way is to have another instance. Instead of having this, you just have to look at the but in this case, it would be a benefit to have giving type of tax here. I honestly like more additional. I mean, what about but the thing, I think yes. But the thing is, the bigger the number of things, like 3 hours, you said. But what about this? All the showing this. You probably have a problem that the rest.
Well, I can't wait to do that, because mine broke and I was like, oh, I have that. That's weird.
And let's think about, so this is if I want to do this. My shopping list. You could have another sharing folder like that. I should always show you this. And if you think about it, yes. This is basically instead of adding already, you have and another here. And you see that all the people discount this. This is an example where we actually oh, that's actually not most of it.